It's interesting that some of the issues that I think we will be addressing today came up yesterday, and I'm sure you have already thoughts about how one would address public spaces when there's a possibility of actually bringing technology to them. So I'm here just to launch the workshop. I'm just going to say a few words, and then I would leave it in the capable hands of our crew here from CCS and the School of Architecture. But let me say some of the few thoughts I have. First, I want to address the title, Hacking Public Spaces. Some of you who have already involved in activities like this already know this, that I want to underscore it. Hacking, in this instance, does not imply anything nefarious, right? The term has been accepted to designate the possibility of citizens getting involved in shaping things, whether it's policy, governance, public spaces, because there's something about the technology that we are using that lends itself for massive participation. So hacking means the possibility of becoming involved in the process of shaping the city. So it's a very positive element. Do you have any thoughts about that? Was that something that you already knew and participated in? Maybe some of you have already taken part in hackathons before, and the term hackathon comes from hacking, and it's something that actually many municipalities have been organizing to get their citizens involved in actually participating in thinking about technology, in utilizing the resources available by means of technology, just in getting involved in this. Another thing is this, and this is really the central theme of the workshop, is getting away, trying to question this idea that the smart cities and the potential that they hold has all to do with this kind of invisible technology, invisible processes. The blurb that we give you speaks about the under-the-hood mechanisms that the technologies enable the cities. And actually one of the speakers yesterday said exactly that, said something about how the technology of smart cities is invisible. We're trying to get away from this. Yes, smart cities imply, the possibilities of having sensors deployed in our buildings and neighborhoods, gathering data that can be utilized in optimizing some services, in creating certain efficiencies, with traffic, waste management, etc. That's part of it. I think the greatest potential is with the technology not only being visible, but actually enabling new ways of actually using the city, being present in the city, interacting with other people in the city. So it's not under the hood. It's very much visible. It's very much one of the things that is very clearly enabling us to do certain new activities in the cities. And this is what we want you to think about. The question is, how can we make our public spaces better with the use of technology? Why do we want to make them better? Because there is a sense that actually public spaces are perhaps suffering because so much of the activity now that we associate with the public arena has been evacuated from the public spaces and now is actually in the blogosphere, in the infosphere. It's happening online. think about Facebook, social media, etc. There's so much activity there. It's intense, but it's not something that is animating public spaces, right? It's not out there in the world. It's in what we call the infosphere. But I think there is a way to bring that activity down, so to speak, to have an impact on the physical world. We want to capitalize on this intense social activity that has been enabled by those technologies and actually bring it back to the public arena. Yesterday, those of you who were here, I mentioned this great app developed for Dolores Park in San Francisco that actually helps people find in the public space their friends, their Facebook friends. So this is an interesting example that allows you to see how there may be a link between that intense activity online and the public arena. There are I have 2 minutes left. There are other examples I can actually read. Chris and I did a workshop like this in India a few months ago in Ahmedabad, and one of the groups came up with this great idea of having a constellation of stations in a public park that are described as almost like electronic soapboxes. So people go there, they have an issue they want to discuss, they initiate a conversation. That conversation is broadcast online. There is an app, there's also a website where people everywhere can actually hear or see a transcript of that conversation. People gather, they know then that the topics are declared and people go to choose one of the topics they want to address. It's all broadcast online. People can participate at home, adding comments, and there is a way to provide feedback to the live conversation with the LEDs that change in color for like or dislike. So there's a feedback provided by the global community. So it's an interesting way to bring what is often happening online with, on various public or social media platforms where there's an intense conversation, but bring it actually landed, anchored in a social public space. Another project I would like to mention, and I will leave, is a student of mine who did a thesis project on how we can use public spaces for learning opportunities. So this was developed for people who are trying to learn a second language, and it was designed for the public space in Toronto, and it went with an app that told you when you arrived at that public space, if you are interested in a particular language, it tells you where to go, where there's a group forming of people who are trying to learn that same language. So it's like the Dolores Park app. Basically, it helps people find others with like-minded interests or desires for learning and aggregate them in a particular learning environment. So those are 2 examples that show you how you can bridge between the infosphere, the sphere of social media, and real public spaces. Those are very clearly smart city applications. So you can see how that's a far cry from the cliche of the smart city as some kind of under-the-hood network of sensors that is gathering data to serve the needs of corporations and getting more money out of it. That's not at all what the smart city is all about. It could be that, but there's so much more. And what is most important for this workshop is there's so much more in the potential of reinventing public spaces reanimating them to make them vibrant, compelling environments that build the bridge between the intense activity online and the material world. So thank you. I'll come back later to mingle and see what you guys are up to. And see you later.
So good morning. My name's Chris. I manage RAD, which stands for Responsible Computer Design. We had a booth yesterday. I don't think I had the pleasure of meeting all of you, but some of you. And I will be presenting some examples that would, I hope, inspire you for today's workshop. So I guess ripping off the dean, we are looking for a new sort of family of sensors or installations that essentially visualize and visualize data at the point of data collection. So showcasing what is being collected while it's being collected at that source. So instead of thinking of sensors invisibly or passively that go to some server somewhere and you're looking at an interface, what are the family of sensors or design solutions in which we can showcase what is being collected at that point and perhaps impact some behavioral changes by visitors and users. So I'm hoping to present 3 projects. They're all done through RAD. The first one is called the Digital Paver, and it's essentially a paving tile that is meant for outdoor use in public spaces. So this is a concrete paving unit that's about 1 foot by 1 foot wide, and it has about 64 LEDs in it. And the grid is maintained so that when you tile them, they continue. So the grid is still maintained, and it essentially activates the horizontal plane as a interface or almost as a display. And this is the sort of plan in the sort of the concrete paver. But underneath it, there's a sort of electronic board in which these 64 LEDs come together. There's a speaker, a motion sensor, all connected to an Arduino. And the idea is that it's not just an output, but it can also receive input. So it can sense motion, it can interact with people, and display information through them. And then this is the plan of the circuit board. In this case, this was a proof of concept and a prototype in which it was CNC'd out of foam, a 2-inch piece of foam. And the idea here was that it was separate from the concrete paving unit in case any of the there was any electrical issues that would arise. Essentially, we could switch out the foam board and still use the concrete paving unit. And so this was this is a drawing of an exploded axle of it in place, accounting for any waterproofing, so that it doesn't interfere with any of the electric circuitry and how it would work with the soil and the landscape. A section of it, where would the water go, and how it permeates through the paver into the soil without ruining the circuit board, and the process in which it was made. So the top house actually, the concrete paving unit was a standard concrete paving unit, which was then water jet cut, and the circuit foam board was CNC, and then all wired. So what are the potential applications? And maybe I'll go through this really quickly. This is just one example in which you could connect to, let's say, Twitter, right? It's very open-ended. The infrastructure is in place in which you can recode it and reuse it. And so in this case, one example would be that it could connect to Twitter. It was inspired by this idea of ripples, and at the center of these ripples were what people were talking about most. So the most important, let's say, hashtags or the current use of, or the most popular hashtag being used now will be at the center of each of these ripples and the latest. And then while, you know, the ripple or the waves outside of each center would be decreasing time, or let's say the later tweets or the less recent tweets would be further away from the center of each ripple circle. And so then they would be, I guess, represented within these pavers. And so you can communicate with these tiles through this app that was made. So I can create a tweet, and it's kind of an idea about what is being said most currently now that you can activate through public space. So this is a connection of social media, and then a diagram of exactly the representation of where the most current tweets are at the center, and then anything later would be further out from the center of the circle. And then a quick render. Another example perhaps is much more simple, but it does kind of showcase the idea that we are visualizing or showcasing what the data is being collected at where the sensor is located. So in this case, we just created a simple box for a sound sensor, and it would change between being happy or sad. So there's a servo motor connected to an Arduino, and basically, if it's too too loud, it would be sad, and if it's quiet, it would be happy. And so it's just a simple sort of sensor box that showcases, hey, the data that we're collecting right now, it's too loud, and that could potentially change behaviors of visitors around this particular sensor box. And so there was an interface that was connected to this. This was showcased at eMERGE last year, showcasing the different ambient noise levels. Renders of where it could be at, and versus quiet versus loud. And then finally, this project is more, so you can think of this, these family of sensors in many ways. One, are they visualizing data for that single sensor, or is it an aggregate of perhaps sensors around, maybe 4 or 5 within a 1 mile radius, and there's a visualization display that showcases the aggregation of that smaller group of sensors? Or are you going to perhaps think of a visualization tool for the average of all of the sensors around a particular city? And so this is a project that was shown a little bit yesterday, and it's a facade system that uses algae within a public space. And so we proposed that we use algae within transparent containers, and each of these containers would have individually addressable LEDs. And so by doing so, we could essentially control the amount of growth within each container. So the more light that gets into that particular container, the more the algae grows, the greener it gets. And so you can start to think of each container as a living monochromatic pixel. That when you amalgamate across the surface, it could become a display. But in this case, algae has many beneficial properties such as carbon sequestration, water filtration, and it can be used as a biofuel. So the idea is that you could potentially hook it up to the building's rainwater or gray water supply and use this facade system to clean that water. You could hook it up to the building's HVAC system and sequester carbon in that sense. And when the image is done, you could essentially replenish the image, but use that algae as a biofuel. So it's a sort of system in which it's all being used. And in this particular case, we proposed it for the Museum of Science, in which there was a plaza below and a public space, and using this display as a visualization tool. And in this case, this bar graph is showcasing water conservation per capita of each neighborhood within Miami. And it's kind of comparing and contrasting and perhaps inciting some change between the different neighborhoods to conserve more water, for example. And then a plan of this particular proposal, and then a section. So how is this done? So I guess I'm going to move towards, there's an app, so you can connect individuals to the public space. Perhaps there could be a public participatory method in which what kind of image gets displayed, a connection to the space without having to physically be there, and then a rendering of it in place. So how is this done? And perhaps we have a wide variety of individuals from different fields. So I guess I will bring this second presentation. And so it's a brief introduction into sensors, and perhaps for those of you who are familiar, this is very introductory. But just to get an idea, I think today it's more about the conceptual idea, but perhaps it can give you some information about how it would work, or how would you implement it. So, physical computing is essentially an interactive physical system made up of sensors and actuators that hook up to a microcontroller, which you can think of it as essentially a really dumb computer. And they essentially work with the physical world, both analog and digitally. And so, really the bread and butter is the Arduino, which came out in 2007 from Italy. The Arduino is a piece of hardware. It's about 1,000 times, let's say, dumber than the computer that we use today. But it's really great for individuals who don't have any sort of electrical engineering background or any coding background. And so the Arduino is the hardware, and the Arduino IDE is the software, in which you're essentially coding what to do, what the Arduino should do. So you can essentially plug in a number of different sensors into the Arduino, and this could be, and then there's a quick slide about there's a plethora of sensors and there's a plethora of actuators. So you can plug in any sort of actuator into it, and that could be anything from, any sort of sensor into it, and that could be anything from as simple as a switch. And then you can plug in any sort of actuator, which could be as simple as an LED, and write a little sketch onto the Arduino to say, hey, if the switch turns on, turn on my light. Or you can connect a temperature sensor and say, hey, if the temperature is above 32 degrees, turn on my light. So this is where the Arduino, in conjunction with the sort of personable 3D printer, has kind of spawned the entire maker culture, and you can kind of make anything and everything now. But of course, we're looking in the context of smart cities, public spaces, and architecture. And so this is a sort of a breakdown of the different parts of the Arduino. It operates, or it connects with about 5 volts of sensors and actuators. So there are a number of sensors and actuators that are meant for the Arduino. But you can also control things outside of sensors and actuators meant for the Arduino. So you could theoretically control your dishwasher or your coffee machine using an Arduino. So they have about 13 digital I/O pins. So those are different outputs, and about 5 analog. So digital, when I'm referencing digital, I mean essentially it could either be turned on or off. So it's very black and white. So basically a light switch would be on or off, whereas analog is a sort of gradient. So it could be a spectrum of values or outputs or inputs. And that could be, let's say, brightness level for an LED. And so they do have a family of products. It is open source, so you could make your own, although they do sell a family of products. And these are a number of other products related to the Arduino family that deal with specific situations and installations. So the Arduino Pro is meant for something more permanent. There's something where you solder your inputs and outputs. You have the Arduino Mini or the Arduino Nano, which are much smaller. So if you're looking for something in a much tighter space, you would more than likely use the Arduino Mini or the Arduino Nano. The Arduino Mega, which is meant for projects that are much bigger, it has a much more powerful processing unit, and it has many more digital outputs as well as analog inputs and outputs as well. The Arduino LilyPad is meant for wearables, perhaps not relevant today, but just for information that you can sew on one of these chips onto, let's say, clothing and make them interactive. And the Arduino Uno is meant for the Internet of Things in the sense that it has already a Ethernet port onto the board. And so these are, subset of actuators. I think that we do have a kit, a couple kits that you can kind of look at to get an idea, but actuators are things that are essentially output. So LEDs are the most basic, DC motors, servo motors, or stepper motors. Stepper motors are more used within 3D printing. They're very accurate. DC motors is more like a fan, for example, spinning like a tire, for example. Linear actuator moves in a single direction. Fan with LCD displays, etc. I mean, there's an entire family of sensors. Actuators. And then conversely, sensors. So anything from force sensors, motion sensors, proximity sensors. So motion sensors operate only either on or off. So it only detects whether there's movement in front of you or not. Whereas infrared proximity sensors tell you the distance between if there's something standing in front of the sensor or not. Photocell resistors detect light. And those are analog as well. Microphone sound detection, soil moisture sensors, sound sensors, temperature and humidity sensors, ultraviolet sensors, and RGB color sensors. So there's a number of different sensors as well, depending on what kind of sensors you'll be looking at. And I think we'll be giving groups essentially a topic, so either like health and fitness, traffic congestion, and so you might want to look at sensors particular to that sort of topic. And then there's also shields, which help give power, for example. That would be the power motor shield. GPS shield if you're looking for a particular location of where your sensor is. Wireless shields, Arduinos don't particularly come with Wi-Fi. So these are add-ons on top of the Arduino. Another point is that there's also a Raspberry Pi, and we do have some as well going around. And there is a difference. Raspberry Pis are essentially mini computers. It's essentially a movement to essentially believe that everybody should have access to a computer, and they're about $30. So they're complete as a whole, whereas Arduinos need a laptop to program into. A Raspberry Pi has a much more powerful processing unit than the Arduino, but it does have some inputs and outputs that it can control with sensors and actuators, although not as many as the Arduino. So it's very common to essentially hook a Raspberry Pi to an Arduino, where the Raspberry Pi is doing any computation. So if you're thinking about sensors and computing anything locally, and then displaying them locally, you might want to think about using a Raspberry Pi so it can do the computation, but using the Arduino for the inputs and outputs. And they also have 4 USB ports, so they can be programmed by themselves. They don't need a computer to attach to it. It essentially has an HDMI port. You can plug in a monitor and a keyboard into it and a mouse, and you're pretty much good to go. There is also a number of add-ons to the Raspberry Pi. There's a Raspberry Pi 3, which is the main sort of computer, and then there's a Raspberry Pi Zero, which is much smaller. So that's kind of like the Arduino Mini or the Arduino Nano. So a Raspberry Pi that's fit for compact spaces. And then there's small add-ons, so you can add a camera if you're looking for any computer vision sort of stuff, infrared camera, and then a sense hat as well. And that concludes a little bit about the sensors.
Okay, so it's becoming clear to me that maybe I should also say a few words to contextualize this presentation. So, like the description of the workshop says, your task today will be in your teams to design a concept for a system that will be integrated into the underline, and we'll tell you a little bit more about the underline here as well, so we have that built in. And the presentations here are intended for you to sort of make note of the things that you'll have to consider in your design. So this is basically to get everybody on the same starting page before you launch into actually working in your teams. So the presenters will be operating as consultants when you're doing your design, so they will be going from team to team, and you can ask them questions and see how your project is going on that specific aspect of the project. And we are showing you the various components because we also have them here for you to play with and for you to put that into sort of the physical world but that'll come after you have your idea. So we have 3 kits that are complete, and we'll be able to sort of break those up and give you guys the sensors that are specifically applicable to the kind of project that you're designing. So about halfway through your design, or wherever you're ready, you'll let us know, and you can which ones you need.
Yeah, but I wouldn't stress too much about any of the technical sort of stuff. It's more about
Yeah.
conceptual design. It's just this sort of background information that would potentially
Right.
help inform any of your design solution or design ideas, and how breaking down it may work.
To get an idea of like how big it'll be, what it might.
Yeah, or what kind of sensors are available to you.
Right.
You might want to combine them together. That sort of stuff. Yeah.
So you won't actually be,
Coding or
prototyping today
anything.
because there's only so much we can do in 3 hours. But the idea is to sort of get towards that stage of where we would be starting the prototype. Okay. Okay, so our next speaker is Joel Zisman, who is the Director of Advanced Computing at the Center for Computational Science. And I'll just let you launch straight into it so that we're staying on time.
Sounds good.
Can you see
Good morning, everyone. My name is Joel Zisman. As Athena mentioned, I'm the Director of Advanced Computing at the Center for Computational Science. I've also been working with sensors and smart cities for the last 5 years or so. We have several programs going on right now with the city of Miami Beach, Coral Gables, Coconut Grove, and the county of Miami-Dade as well. Today I'm going to talk to you very, very quickly about IoT connectivity. To me, this is a fairly important topic. I'll be talking about security a little bit later on, which is even more important to me. But the thing I wanted to get through here is that we should never forget the first letter in IoT is for internet, which means that everything that we have needs to be connected. You can't simply have a standalone sensor by itself doing something. That actually defeats the purpose of a smart city or an Internet of Things. So I'm going to talk today a little bit about how we actually connect these sensors together, these things together, whether it's Arduino or a Raspberry Pi. Most of this is going to be fairly technical. I'm going to go over it very quickly. It's just here to get people thinking about the different types of connectivity options you have and how things have changed since regular computers. So here's very quickly what we're going to cover. As I said, why are IoT networks different than regular networks? We're going to talk a little bit about the OSI network model. I'm not going to go deep into that. That's just the standard model we have for networking in computers. Then we have an IoT model, and then we'll actually get to what do we mean by networking. And then finally, we'll get into some thoughts about sessions and programming. So first of all, why are IoT networks different? First of all, the scale. I'm sure many of you have heard over the last couple of days, if not the last couple of years, how many of these devices we have in the universe today. Currently, there are about 8 to 12 billion connected devices today. This number is pretty broad, and the reason it is because nobody's really quite sure how you define an IoT device. So if we count a light bulb, for example, as an IoT device, you're going to go much further to the 12 billion number. If we go, we're talking about things that actually communicate and react, closer to the 8 billion number. Take a look at what's predicted to happen in the next 2 to 4 years, however. We're going to see an increase from 45 to 50 billion devices. By the way, this is a number that I found consistent among just about every IoT consulting group there is, from Gartner all the way across. So this number is actually fairly accepted by the industry right now. The other thing that makes it very, very different is diversity. Okay? When we have computer systems, everything's pretty much the same. We're operating over Ethernet, whether that's wireless or wired. When we're dealing with connectivity for things, as I said, such as light bulbs or microwaves, they don't follow the same protocols. So we have to bear in mind that the network itself is extraordinarily different. The other problem we have is that, whereas we have for regular computers, everyone knows about Wi-Fi, right? It's an accepted standard right now. That doesn't exist necessarily for IoT devices. While there are such concepts such as Wi-Fi and Ethernet in there, they're greatly scaled down, and they don't have the same impact that they do on computer systems. So right now we're seeing a lot of split across the entire industry as well. And as I said, there is no clear model for networking right now. There has been a clear model for over 30 years, 40 years in PCs and regular computers. This doesn't exist yet in IoT because it is still an emerging technology. And that's something we should all bear in mind as we're doing our projects. This is emerging. What you're doing will actually affect where the technology goes in the future. And then finally, one of the biggest problems that we have are constraints. Okay? We can't put a computer every place we want to put a sensor. Too much power, not enough space, what have you. So we're always going to be constrained by what we're doing. This may be physical power, throughput, or very, very important, reliability. A standard Internet of Things device, we only expect to be about 50 to 60% reliable. We don't expect the 99% reliability we see in regular PCs. So make sure you compensate for that whenever you're doing your designs for your projects. Some basic terminology to deal with. I'm bringing this up to show you the difference of way things work and how they are today. For anyone that's curious, in RFC, simply a request for change is something called the Internet Engineering Task Force, IETF. I recommend you all take a look for that on the web. You too can be a part of how the Internet is defined for the future, and that's where that site is. You can actually sign up and be a member of these projects. So we define networks for IoT in these three ways: constrain, challenge, and LLM. Notice we don't have anything up there about how robust these networks are. You can do anything you want with them or what have you. Nope. These networks are simply going to be there for as low power and as minimal requirements as you can have. And remember what I said beforehand about reliability. Okay? So if you ever see any of these three things beforehand, you know what we're talking about. It's a regular network, but it's going to have some problems with it. So always bear that in mind. Before I go any further, the first L here is fairly important. Does everyone know what lossy means? Raise your hand if you know what lossy means. Okay, no problem. Lossless is what it may sound like. There's no loss in it. Lossy actually means that there is expected loss. So we're actually designing our networks so that we know there's going to be problems.
I think you're right.
Cool. I'm not sure how I managed that. Let's all look at this model right here. It is a lossy presentation, exactly. Here we can see 50% packet loss. I'm not going to go through all the different layers that we have here. This is what we refer to as the OSI, Open Standards International Model. This is what networking looks like whenever you send a packet or a piece of data on the internet. Okay? It has to go through all these steps just to be transmitted. And then it has to go through all these steps just to be decoded on the other line. As I was talking beforehand, as you can imagine, with lossy networks, that doesn't work so well. All those steps have to go through every single thing, whether it's an Arduino, like Chris mentioned earlier on, light bulb, microphone. So we found out that this, well, it just doesn't work that well. So what we found out was I reached out to a couple of friends of mine at ON, who's one of the leading groups dealing with IoT development right now, and they sent me their particular model that they're using right now. Looks a lot simpler, doesn't it? Okay? And most importantly, if you notice, those 7 layers right here are really all constrained to those bottom 3 that are right there. The idea is not to have you memorize what we're talking about with UDP, DTLS, and all that stuff right now. It's just to show you that we're really simplifying the network as a whole. And when you're designing your stuff, you need to simplify as well. Okay? Now the thing that everybody really wants to talk about, which unfortunately is not being shown over here. These are the actual networks that you have a choice of whenever you are designing any form of IoT sensor. Okay? We all think about the top one right here. This presentation is going to be available. Don't hurt your eyes trying to see it right now. The top one right here is Wi-Fi. Okay? We think of Wi-Fi as being ubiquitous these days. It's everywhere, right? Not with IoT, it's not. Turns out that of the 5 projects I've done over the last 5-6 years right now, not one of them has had Wi-Fi that I've been able to use. So we have to build your own network for the most part whenever you're doing IoT development. And these can be new things, as we're seeing right now, OnRamp and Sigfox, which will have very, very small data rates, but will be able to transmit for hundreds of kilometers, all the way to things such as Zigbee and Z-Wave and Bluetooth, which are referred to as personal area network devices as well. So whenever you're dividing everything, I don't want you to think that the only restriction that you have, or the only network you can choose, is Wi-Fi. It's not. Look at what you're designing, and then look at the network you can have for it. And then finally, I'm going to go right here real quickly. This is once again just showing you a simplification of what we're doing for our design in the stack. And is the Internet Protocol enough? And we find out that what we refer to as years as IP, the Internet Protocol, simply won't work for IoT. So we're redesigning it. Everybody's redesigning it from scratch, and that goes for everyone who's building. So I want everyone to think of themselves not only as an inventor of Internet or of sensors, but also an inventor of networks and the Internet as well. I'm not going to go through all these. These are here for anyone who wants to take a look at them. These are more advanced programming topics that we have. If anybody has any questions on this, I'll be circulating around later on. Thank you very much.
Okay, so next we have Barbara Millett from the School of Communication.
Good morning, my name is Barbara Millett. As Athena mentioned, I am a faculty at the Cinema and Interactive Media Group, Media Department in the School of Communication. I'm also director of the User Experience Lab, and this talk will be less technical than what you've seen previously. Give it a little bit of a reprieve here. Okay, so how many of you can tell me what user experience is?
It's the experience.
What did he say?
Experience of the user.
Experience of the user, okay. What does that entail?
How they interact with
How they interact with
all the sensors and anything.
anything they interact with. That's exactly right. So there are many definitions for user experience, and believe it or not, there's no standard definition. And the reason why is because the user experience can be viewed very individualistically. So a standard, well, not a standard, a general definition would be that user experience encompasses all aspects of a user's interaction with and perceptions of the product and related services. So this is really key, perceptions, because that's exactly what it is when we're talking about the individual's user experience. It's their opinion, subjective opinion of your product, of what you've developed. So user experience, though, is a multi-construct process. And it starts by being useful. Does it meet the user's needs? It then must be easy to use, right? And then after that, it has to be something that you enjoy interacting with. You have to enjoy the way it looks and the way it feels. That brings in the desirability aspect. And then all of those layers contribute to how you feel about the overall experience for the product, and that translates to the company that sponsors it and the services that surround it. So any bad experience with any of those aspects kind of ruins your perceptions of how useful, usable, and desirable that product is. And this is from an individual's perspective. But user experience is a process. It's what you do to create products that provide good experiences. And there are 3 different types of processes for creating user experiences. There's Agile, there's user-centered design, and there's Lean UX. Are you guys familiar with any of them? Yeah? Yay, okay, good. You want to tell us about them? So all 3 processes, so no interaction today, okay. All 3 processes have the same 3 fundamental concepts, and that's early involvement of users, having an understanding of what who the users are and what their tasks are, empirical measurement of product usage, and the last one is iterative design. And so this is a 4-stage approach. This is the user-centered design. It's the original model for creating experiences. And basically it starts with having an understanding of who your users are, what they're going to do with your product, and what is the context of use, okay? And then that goes into design and implementation. And that's where you translate the user requirements and really innovate solutions, well not solutions, concepts that are going to be still evaluated by the user to make sure that you're meeting or exceeding expectations. And then it comes to evaluation, and although evaluation stands as a separate stage, there is evaluation that happens during this design and implementation phase. And in evaluation, this is where you're doing more of the empirical measurement of the product's utility, usability, and desirability. And there are metrics that you follow. Some of the standard ones are efficiency, effectiveness, and satisfaction. Some of those are performance-based, and others are more on the emotional response that the product elicits. And then the last stage is long-term maintenance, and that still gives you an opportunity to have a user touch point because you get feedback once your product is being used, right? What are some of the venues for getting feedback?
Getting feedback to the user. Direct interaction with the user.
Sure, but you also get some indirect from like technical support and other venues, you know, and you get to see how the experience evolves with time, right? And that's not something that you get to see early on in the stage 3 part of the phase. Okay, so at the most basic level, in order to design great user experiences, you need to know who your user is, and you need to kind of have answers for these questions. So who is the user? What are they doing with my product? How are they going to do it? When are they going to do it? Why are they going to do this? And where? Because all of this informs what are the things that you need to think about when designing your product. And this comes from Jesse James Garrett, and he wrote a book, probably late, maybe early 2000s, about the elements of the user experience. This has been adapted, but it's been a model that's been used since it was released. And this is something that I'd like for you to be thinking about when you're putting your challenge together. And think about the experience as developing a great user experience as having multiple layers. And it really starts with your strategy. So what plan are you going to put in place to achieve the goals that you've set forth? And those should be dependent on the problems that you're trying to address, which comes from what do your users need? Then it goes into scope. And scope is really about transforming that strategy into requirements. And that entails what are the features and attributes that the product should have. And then it moves on to structure, that's giving shape to your scope. And essentially, I keep looking over here, and this is not my phone. How do these aspects fit together? And then the skeleton is what supports your structure. How are we going to be able to enable use and interaction? And lastly is the surface, and that's the sensory experience. So what is the end user going to be really interacting with? How does it look? How does it feel? What does it sound like? Because in smart cities, we're not just dealing with visual interfaces. And this is Claire Rowland's model. She just released a book, I believe, a year ago about user experience of Internet of Things. And her model describes the different layers that are needed to achieve a great user experience for Internet of Things. And she talks about how, although they're going from least visible to most visible, they all contribute and build upon each other. Something that stands out from this model is these two aspects, and I wanted to just point out these two aspects. It's interusability and the conceptual model. So interusability comes from the fact that in order to have a system that for the Internet of Things, it's dependent on devices and web services. And these may be made up of different types of devices that don't have the same form factor. Some don't even have interfaces. So you really need to be thinking about how all of these different pieces are going to work together and ensure that it provides a coherent experience for your user. And the conceptual model ties a little bit to what Dean L. Curry was saying about how tech is invisible, but it's visible. Because the conceptual model ties back to the fact that you really need to have your users understanding what it is that they're working with, what are the components, and how they work together. And this stems, so I'll give you, and this is because the Internet of Things, it's complex. And they depend on each other. So how many of you have smart systems where you can turn on your lights when you're not home? Okay. So if you think about the traditional way of turning on your light, you flip a switch, electricity flows, and your light's on, right? Well, that's different when you're using a device, right? There's like gates and hubs, and it's dependent on web services to make the light turn on, right? Your light bulb has to be connected. And if the user user doesn't have internet, it's not going to work, right? So these are all things that if you don't understand how it works, then you don't know how to deal with the complexity of what you have, because there's many more points of failure than the traditional approach. So some considerations for you while you're working through your challenge is that you have a wide variety of users when you're designing for the smart city. They're going to have different experiences, skills, and motivations, and context of use. And think about that the user flow is going to be different across the devices. There's going to be different interaction paradigms, and there's going to be different contexts of use. Thank you.
All right. Good morning again, everybody. Good morning. So, for the last talk that we have right now, last presentation before everyone gets on to your projects, we'll talk a little bit about IoT security. So very quickly, I'm going to go over some common threats that we've seen over the last year. I'm going to go over some ideas about network security, platform security, and program security. We'll see how much we have time. So let's go over some threats that we've seen around the world within the last year or so. Every time I give this talk, I go through and I update what I've seen. And there's only one commonality I've had since the last time I gave this talk about 3 months ago. And I've left that there intentionally. So to give you an example, let's go over some things that have happened recently with Internet of Things hacking. And in this case, I don't mean hacking in a positive sense. I mean hacking in a negative sense. And some vulnerabilities that have been exploited over time. The first one is a fairly mild one. It doesn't seem like it's a big deal, but when you look at it in retrospect, it's actually quite concerning. In April of 2017 in Dallas, the hurricane warning system was actually successfully attacked and penetrated. Okay? 156 sirens across Dallas went off for 90 seconds at a time over 15 times in the span of 24 hours. Okay? Now granted, this made it difficult for people to sleep, what have you. But think for a moment that this is an actual penetration of a governmental warning system, okay, that was done by external actors, okay, and it actually set off everything. Anyone want to take a guess how this was actually exploited? A firewall. Okay? Turns out that with a fire alarm, some smart person was able to figure out that it sends a signal back. Someone sent that signal back and activated the entire warning system. This wasn't a particularly sophisticated attack. Okay? This was done by a kid. Okay. Ukraine. Let's talk about governmental actors for a moment now. Okay. In 2016, December 2016, several substations throughout Kiev were taken offline. Okay. This resulted in the loss of 200 megawatts of power throughout Ukraine throughout Kiev for a period of over 3 weeks. This resulted in roughly 20% of the city being shut down at any given time. Okay. Anyone want to guess how this one got activated? Sorry? Russia. Yeah. It was, it was the Lucky Puppy hacking group that did it. But the way they got into here through this of all places was, well, somebody left the website server unprotected. Went right in, post methodology, bam, took the whole substations offline. Okay, the Ivano-Frankivsk region, okay, an entire region of Ukraine brought offline for 2 months. Every time they started the power back up, boom, went right back offline. It wasn't the same attack. Okay, they don't even know what the vector for this one is yet. They're still trying to figure that out. San Francisco, who here heard about the San Francisco train ransomware attack? Okay? Someone actually held the light rail system in San Francisco hostage for 4 days. Once again, unprotected web page. Someone was able to get right in, take care of it. Benelux, fall 2017, lost close to 2 billion euro. How did they do that? They gave people the opportunity, the ability to print their boarding passes at home. Someone figured out these passes weren't serialized. Okay? But 45% of the ridership on the Benelux train system is rode for free for 6 months. One I always bring up here, the Dyn botnet attack. How many of you remember that? Dyn is a service that runs DNS, or is a company that runs something called DNS, the Domain Name Service. The Domain Name Service is a cornerstone of the internet. It actually is how we translate what the name www.google.com is into an internet address of 8888, which computers understand. Okay? Dyn is one of the largest DNS servers in the world. Serves over 35% of the United States internet traffic, 65% of South America, 100% of Latin America. Okay? IoT devices, the ones we're talking about right now, we're in a distributed denial of service attack against Dyn. Knocked them off for 4 days. Posters, microwaves, TVs. That's what was used in the Dyn attack. It wasn't computers or anything else. Okay? And then finally, some regular hacks which you may have heard of. How many of you own Samsung TVs? How many of you now know that you can be listened to at any point on your Samsung TVs? Once again, state actors. This is not a bunch of kids. And then finally, let's talk about the Wi-Fi waiting line, one of the ones that started it all off. How many of you have used these before? Hey, I do. My grandkids use them all the time. How many of you know that not only can they receive off of them, but you can transmit as well? It was a very, very scary case about 3 months ago that I ran into. A buddy of mine in Chicago, someone was actually talking to his granddaughter. Luckily, this was not anyone with any malicious intent in mind. But it does go to show you, these are not isolated incidents. Anything we put out there as designers, as inventors, as engineers, we need to think about security. Who knows what the current state of security for Internet of Things is? Anyone want to take a guess? Doesn't exist. We don't even use usernames and passwords on Internet of Things devices. Okay. We're going to talk right now about, very, very quickly, about some common sense steps you can take to make sure that you don't put out a bad product or get yourself hacked as well. It's happened to me several times in my life. Okay? First of all, network security. How many of you have thought about designing an IoT project, have done an Arduino or Raspberry Pi at home or something? I do it all the time. Okay? How many of you put it on a separate router? You're smart, Chris. I don't. You should. Or buy a Linksys 54G or something like that. Make sure your own network isn't vulnerable. Okay? Make sure your networks are separate. Okay? Segment networks. Make sure you have a firewall turned on. And this last one, I beg everybody to do it because it bit me not that long ago. Turn on login and read it. This is not just for IoT devices, but for your routers and your PCs as well. Okay? We had a very bad hacking attempt go after our lab not that long ago, which if I had read the logs, or some of my people had read the logs, we would have realized it, we could have dropped the IP addresses off. Instead, we were dealing with bad bandwidth for about 3 months. Okay? So even professionals get bit by these things as well. Okay? And then if you are doing anything with IoT, if you've ever seen this UPnP, Universal Plug and Play, turn it off. Go to your router when you get home. Turn this off. It is the #1 attack vector being used right now in IoT devices. Okay? What it means is that you send a broadcast signal out from your router, your devices receive it and say, hey, I'm here. I'm going to join your network. Sounds great, right? So you get rogue devices on your network and you don't know what they are. This happens all the time. Platform security. Not going to go too deeply into this. I'm going to circle around. If you're talking to people, bear in mind that Internet of Things is essentially machine to machine. What Dino Correa was saying that we're trying to get away from under the hood. But bear in mind that just about every device you have can speak to another machine. So make sure you know what your entry points and what your exit points are for all data. Okay? Programming security. How many programmers are there out here right now? All right, good. I'm on board. needless to say, where I was talking about how we don't authenticate versus a device, this is a step that we're taking to try and do it right now, or to. Okay? If you do any software design in the future, take a look at this. And then finally, going back a little bit to what I was talking about, programming security. Remember I went in my first talk, I talked about the IP stack and how big it was and everything? Start looking at alternative stacks. Start looking at things like TOPE, DTLS, programs like that. They'll embed your security for you with only a library attachment, and you can avoid 90% of the issues that we're talking about today. And just finally, sort of show you where all this all fits together from a base. Well, if it were there, I would be showing you how this all fit together. Going down from everything from a network link, where I was talking about Wi-Fi networks, long-range WAN, things like that, and how this goes all the way up the stack and across through security. So whenever you're designing something, as I said earlier on, bear in mind you are responsible for the whole thing, whether you want to be or not. So I just want everyone to be careful when they're programming and when they're designing any of their solutions. Don't be the reason another attack happens. Thank you very much.
Okay. Let's thank all our speakers all together once again. This is really so in the next 15 minutes we have a break. So the bathrooms are right through there. You can get some more food. I do have 2 people planning to switch teams because of how it worked out with everybody that arrived. So Shirley, yes, you're now in Trafalgar Square. And so I'll take my semester back. And then Stephen George is right there. You're now in Times Square. So we have 5 teams in total, 3 teams of 4 and 2 teams of 3. We've assembled the teams such that we don't have the same discipline represented twice in the same team. There's a lot of research that shows that diversity is key for innovation, and we also wanted to prioritize you seeing other perspectives from so if you're an engineer, to be paired with an architect so that you can learn from each other's disciplines. So the 5 tables are all going to be used by the teams. So when we come back, you may not be in the same spot that you are now. I'll make a note on these notepads, on the white sheets of paper, which you can use when you're brainstorming with your team, so you can write on these with the markers that are here. So while you're on break, I'll write on them which team is where, so that you can find your spot when you come back. Questions? Okay, great. So let's do that. This was 15 minutes. Our 15 minutes are up. If everybody can please take their seats, and then we'll get started again. We don't want to take any more time away from your actual working and brainstorming session. Okay. Has everybody found their table for their team? So these are named after city squares as one of the types of public spaces that we could be hacking. But today we're focusing on the underline. So the underline is a project that started, was it 2015 or so?
A couple years ago, I don't know.
Yeah, about
It's
2015.
been an ongoing project.
It's the revitalization of the area beneath the metro, right?
Yes, so they're building this underline underneath the metro rail, and it's conceived as this public 10-mile linear park. But it's a lot more than that. So this one is actually a link to their actual website that does look like that. I'm not really going to go through it because really all you need to know I've already said. Except there are some more specifics about the different parts of the line that you could be focusing your design on, if you wanted. And on your table, there's also 2 copies of this, and there's a lot more information on who's a part of it, what it's for, the parts of it that had already been completed at the time that this went through the Miami-Dade legislative agenda, as well as a little bit of information on the design team that was selected to actually carry out this project. So that may be useful for inspiration for you guys. So this is here for you to use. You can also use your phones and your devices to pull up the website or any other news stories that you want for inspiration and what you want your project to be. And last thing that I'm going to say is that at 1 o'clock we'll have presentations, very informal. So it's up to you to either select 1 member of your team or 2 or 3 or all of you to come up here and tell us about your idea. You can use the boards on the side to sort of sketch out what the idea is if you want to or not. If you don't, it's really very freeform, so it's up to you. And you will be expected to have incorporated the feedback of the consultants who will be circling from table to table to help you with the designs, okay? So, and at the end of the day, then we'll have, we have a little award for the winning team that each of you can take home. So, I think that's all that I want to say. Am I forgetting something? I think that's all.
Are each of these groups assigned to a topic?
The topic is up to you to choose. So you can choose any part of the underline that you want.
And you can focus on,
And you can,
yeah, if you wanted to focus on health, like leisure, I mean, the underline is meant to be this 10-mile, almost like park, which could be in different sections that relate to health, fitness, activities, play. So you can focus on, sensing, I mean, it's right beside this one, so you could also potentially focus on traffic congestion, there's air quality, perhaps health and fitness. There's a number of different topics that you might want to focus on one.
I can put up the topics that you can sort of choose from just as a starting place for you to start your brainstorming from the list that Chris just mentioned. Yeah? Would that be helpful?
Yes.
Okay. Yeah, you can write them on that board. And the last thing is to not forget about this connection between virtual activity and animating public spaces that the dean was talking about this morning. So that may be something that you want to incorporate in some way. But we want to emphasize that this is up to you to design what you want to design. Okay, so this is the constraints are very minimal, really. Yeah. Okay. So you can get started. You have until 12. Then we'll break for lunch, which will be here. So if you feel like you're on a roll and you need more time, you can also take your lunch back to your table or eat outside, whichever one works for you. Okay. So it sounds like all the teams are ready. So we'll give ourselves a little extra time and get started now. So how about we go in a spiral like this?
We go first.
So you would go first, second, third, fourth, fifth. Yeah? So the way that we'll do this is you'll have a few, so we need to use about 10 minutes for each team, including the questions. So we'll use a few minutes in the beginning for you to present your concept, the user experience and the hardware and components that are required, and then we'll hold the questions from the consultants, judges, until the end of each presentation. Okay? Okay, so do you have one person to present or all of you? You will present. Okay.
Can you tell me what's the table name?
Yes, yes, your team name. The Piazza San Marco.
problem.
Judge Lopez.
Present to the world.
Hi.
My name is Eric Machado. Those who know me know I love talking. Right? Okay. So the problem, right? We tried to encapsulate this problem within the area of the underline. And really it's kind of a first world problem, but nonetheless, it's a scenario that could exist in real life. The idea is when you're at the underline, you want to spend as much time as possible there, enjoying your day, not having to worry about where your things are, how am I going to get back to where I need to go. I mean, transportation is already there, right? You have the metro system up above, you have the trails down beneath that go through the length of the 10-mile strip, so transportation is there. The issue is, as you progress through your day, you will accumulate things. In fact, you may start off the day with things. You may have a bag for your exercise gear, or you may have your bike, and then you may pick up something in a store, or buy something else along the way, or your kids happen to accumulate stuff and want to carry it home. Now you've got all this stuff, and it's hindering your ability to easily transport yourself up and down the underline. So using the facilities that are already there, including the rail system, we envisioned a system where it was enhanced and modified a way so that we can convey goods up and down the length of the underline at a user's preference. So it doesn't matter where you start your day in the underline. You could register yourself and arrive at a station at the underline where you can check in or acquire goods and then deliver those goods to a personalized storage area, which then, as you progress through your day, those goods can then be dropped off anywhere along the length of the underline at a moment's notice. So, you know, imagine, you start the day at Dayland Mall, you may need to finish your day at the airport. You may need to check out for the day. You may accumulate a bunch of goods at Dayland Mall, go shopping, but you don't want to carry that around for the rest of the day. Well, check it in at your personalized check-in location. It's a transportation system that goes up and down the rail system, so as you continue up and down the underline, you can access and load more goods and pull goods out at any point along the strip. It's a pretty simple idea, right? So, I think I got lost. 1129.
Change that.
So, that's kind of the idea of the problem, and the solution. What does it solve for the city, for the area? Well, we're in a sense, we're alleviating a little bit of the transportation issue, because now you don't have to have your car to carry your goods up and down the strip. Your goods are literally following you wherever you want, theoretically, right? I mean, you're depositing these goods in a safe space, and you're accessing them at an exit point. You don't care where they're stored along the way, you just care about that you'll be able to get them when you need to get off the underline and move on with the rest of your day, right? The typical user experience is kind of like what I described. You know, it's kind of a check-in, check-out system. We don't envision it necessarily being 100% robotic. I mean, in a perfect world, we would involve people in this to employ people to actually, let's say you're at an area of the underline that is slightly separated from a drop-off point where your goods can be delivered to you. Well, then people can load it up on a tram or whatever and cart it out to you if needs to be. So you're employing people as well, kind of like a personalized Uber type thing, in a way, right? The technology requirements, well, it would help, but we don't want to limit it to just people who have access to smart devices, but obviously if you do, that would kind of be an easy step into the game, right? You'd be able to register yourselves, check your goods in and out, follow your account, pay for your services. But as, you know, she and I were kind of envisioning, we shouldn't limit this solution to just the served. We need to find a way to get the underserved to be able to participate, right? Because otherwise we're excluding people from the service, which shouldn't be our goal. So, with the addition of digital signage systems that have sensors and cameras in place, you can build kiosk points along the length of the underline so that you can access not only this system, but this system amongst a myriad of other systems that may involve health, exercise, public safety, and access, in this scenario, the goods along the length of the underline. So check in at a kiosk, select your account, access your goods, tell the system where you'd like your exit point to be so that your goods would be ready for you there, and you didn't have to use a smartphone at all to do that. You can just use a kiosk station that's consisting of digital signage, cameras, and sensors to accomplish that goal, right? So that's how we get the underserved to be able to participate. Of course, there is a digital literacy component that we probably need to address. If you're completely computer illiterate or you have no knowledge of technology at all, it may still be difficult to get on board, but we're hoping that the publicly accessible kiosks can still include more people into the solution. Does that make sense? Any questions? Hi.
Is there a cost?
Sure. We didn't envision this to be free, but it would be lovely if it was. But what we discussed was that, you know, what a customer may store at these checking points could be anything from a small bag all the way up to maybe a bicycle or something quite large, right? So depending on what and how much goods you're accumulating, the cost may vary. There may be, it's possible to envision a point where small goods could be free, since the transportation system's already there, but, you know, if it's, 400 pounds worth of gear,
And
then
we're
that,
going to go out to the roof of the city or?
it could be a municipal service or it could be a third party.
Having a vision how much we charge?
No. Not yet. Why, you want to open a business?
No. It's important that whether it's cost effective for people
Sure.
to do so, because it's adding on to if you go shopping, for example.
Right.
And you're going to pay to transport your goods, yeah, I know it's not like, they do something like that in the Camino in Spain.
Right.
But that's a long, long distance, so people don't want to carry their backpack.
Right.
But again, you have to see if it's valuable to the customer. I'm just.
It's a good place.
And it's free shipping. If you have an Amazon Prime account, that
Yes.
So does that automatically imply that you can only deliver things within the underline? If I move away from the underline, it
Well-
should be limited to that?
No, we actually thought that maybe the entire metro system could be used for this service. Initially, we were trying to constrain ourselves to accomplishing the goal within the underline, but then we realized that the whole metro rail system is available to run these goods up and down. So the airport should be involved, the metro mover system downtown can be easily roped in. But
Okay, so-
I'm not sure outside that realm if we're,
Okay, so where the infrastructure is in place, that you can have these delivered.
right.
So in the case that if I move away from it, I have to go back to the nearest stop.
Right.
So what are the harbor and the component requirements? Something that-
On the customer side, you think about it, the goal was to make it all inclusive. Oh, you talking about from the infrastructure side or?
So to build this.
Yeah, you would need to kind of revamp the metro rail stations to handle all this new influx of gear that people are storing, right? So there would need to be some development, redevelopment of these metro stations to handle their new role, not only as just people moving stations, but also good moving stations. There may need to be expansions to the actual rail system. If we want the system to be more on demand than what the metro currently provides, we may need to build a tertiary rail or maybe a suspended rail underneath that runs the goods back and forth. But since the concrete stations are already there, it would just simply be an add-on. Or we just use the train system itself and just modify the train system to allow spaces to store goods so that they can travel with the rail system.
Any other questions?
Are you going to address security concerns? We've had a number of ones from the front all the way to physical.
Right. So,
We're talking about storing large goods and transporting them on a highly attractive target.
right. Okay, so, yeah, we failed.
It's just something you need to think about.
Sure.
So the presentation is in the beginning, or is it as a primer
Right.
for those directions?
Okay. So I guess we need to go back to the drawing board. Think about that. I mean, there's obvious, off-the-cuff ideas of proper check-in and check-out methods, inventorying, scanning the goods to make sure there's no bombs or, dangerous items passing through, firearms, stuff like that. There's concerns with the safety of the goods. If people are stealing the goods, have access to the containers. There's concerns with, there's a myriad of concerns. The system itself will need to be secure so that customers don't lose track of their goods or that people don't gain access to the system and steal other people's equipment. So yeah, we were working on the good stuff first and Probably should have thought of last year.
What is the visitors' interaction? Is it just dropping off and picking up? Do they have information of where their goods are?
Yes, that's the idea, that they can have a portal to view through their account where all their goods are stored, and then just create like a meet point so that the rail system can transmit all their goods to one final destination, if you will, to access the
Can you
goods.
like request a
Yes.
destination here?
That's the idea, yeah, so if you're headed to, South Miami, if you know you're gonna be at the airport, or if you're headed to Dayland, you can request it by 4 p.m. all your goods be at this station, and then by courier service,
Anything that you would like to add?
Well, one of the things we envisioned was when you're going through the city throughout the day, doing various activities, people typically carry backpacks. So one of the things we thought about was having generic backpacks, each with an RFID or some type of ID or embedded sensor in there, so you can basically exchange the backpack with, say, your gym clothes for your evening clothes or shopping or something like that. So you maybe have 3 sizes, you have a backpack, you have 2 sizes of storage containers, so each has an ID sensor in it. So basically, it's modularized, so when you're thinking about storing these things inside, say, the cargo compartment of the train, it's easily storable and easily retrievable because they know the size, they know the weight. It also makes it easier when we envision, similar to your experience at an airport where we're scanning for security, the size is more homogenized and standardized, so it can pass through a sensor or some type of detector or scanner, excuse me, more easily. So in terms of, I'm sorry, so the question was in terms of how to convey these things, it would be effectively just having sensor-enabled backpacks that basically just carry your stuff, deliver it to you, hold it for you on demand.
Okay, thank you.
He's got it.
Low tech today. So good afternoon, everyone. How's everyone doing? Good. Lunch? Okay.
What's your team name?
My team is Times Square. Okay, so my name is Richard Gibbs. Team members Stephen and Delia. And the idea that we came up with actually we kind of took a look at South Florida's ecosystem, right? And we understand that, we're going to use the underline. And South Florida has 2 seasons. It's either hot or it's either not so hot. And you obviously have a period of time where, you have people from the Northeast who come down here during the season, and when they're gone, it's usually hot and it's the summertime. So this was actually part of the inspiration. And I thought about shade. We thought about, well, what does the underline provide? It provides shade, it provides some, modicum of shelter. And we could take advantage of that shade and do a number of things underneath that shade and bring people out who might not normally come out during certain times of the year, right? So essentially the concept was to get people out of this air-conditioned fake habitat that you live in for a good part of the year, pull them out using wellness and social inclusion and diversity. And by that I mean, there are elements underneath the underline that we would promote. Cultural things, meeting places that would bring people out and have them walk through the underline and get them out into the outdoors to improve their wellness and their well-being. So to do that, we kind of have a 3-pronged approach. We're taking the user experience and we're using art with artificial intelligence, art sculptures that could be located underneath the underline that promote people to walk from one part of the Underline to another to experience some type of cultural activity. It could be an art sculpture, it could be a performance, it could be an art show with a lot of vendors. And basically the concept would be, you can have an app and sensors that give you a certain amount of information about one display or sculpture or exhibit. You go through that process of having that experience at one station, if you want to call it that, and then it pulls you or encourages you to go to the next station, and it can track you through sensors underneath the Underline and using an app. The other component of this three-pronged setup is wellness, and the wellness stations would work in a similar fashion. You could have a station for biking, you can have jungle gyms, you can have other fitness activities, all underneath the 10-mile expanse of the Underline.
Stage training.
And you can have a certain amount of stage training, if you want to call it that. And it can pull you from one exercise station to another all along the length of the Underline. And you can also actually have an app, or if a better word might be like an Underline Fitbit, that kind of pulls you through the Underline and tells you how many calories you burned, how many steps you've taken, and it encourages you to walk through the Underline. And then the third part is to add some type of some retail component. So you're out there, you're taking in the art, you're doing exercising. You need a little retail therapy. You need water. You need to buy refreshments. There could be a component in that also pulls you along to retailers, and you could have sensors that tell you what the upcoming retailer might offer. So it could be a juice station, it could be food, it could be t-shirts or something else, and it's a total experience, a kind of user experience that pulls you through all these three different facets that we've come up with. So what is the hardware and the software associated with doing that? So we would need webcams to help with some facial recognition to identify people as they go through the Underline. We thought about sensors when you get to the water sensors. When you get to the exercise stations and you're really hot and you need to cool down, there could be some cooling stations or activated mists that come into play. Motion sensors that detect what type of movements you do, and maybe some of the different exercise stations as well, to tell you how fast you're going and monitor your activity. And the good thing about it is they're both day and night components of this that could be offered. So there's some activities that would be more popular during the daytime, and some activities that might be more popular at night. So there's a two-phased period of time that you could take part in this type of activity. So the type of actual hardware that we would use would include motion sensors, big sound sensors, tracking, some type of tracking system or GPS, temperature sensors, and let's see, what's the last thing? Facial recognition sensors.
Humidity.
I'm sorry, and humidity for the sensor areas. Any questions so far?
Richard, I want to add one thing. There's a scalable app which starts from a facial recognition where it requires nothing of the user. They're recognized, they can track their progress along the path, they do stage training, you can give them little maybe mini screens of little gold coins like a computer game. You did something good, you got a gold coin, you go to the next one. And then they can just, at the next, they can voluntarily go to the next level and say, I want to put in my weight, height, gender, and have my individual exercise information. And then interface that with the employer wellness software that physically gives people compensation or lowers their out-of-pocket costs for healthcare related issues or costs, and interface that with getting pretty sophisticated software that's already in existence, includes it and gives them the benefit and has one more thing that happens automatically.
anyone hasn't guessed, Stephen works in insurance, so. All right, any questions? There's got to be this question. Athena?
The concept is very wide, so
Uh-huh.
I'm not able to focus on one question.
Okay.
So if you had to prioritize, which of these components would you choose?
Out of the three?
And even within the three, those are still very broad categories, right? So you're talking about wellness and you gave us some more specific ideas, but you have a ton of different ideas under those, which makes the sort of the specification of both the user experience and the hardware a little bit more difficult to do.
Okay. So if there's one thing that you would have to prioritize, obviously you'd have to start off from, just the exercise part of it. The walking, just getting people outdoors. That's the first part of it.
But it's a broad idea, but everything is interconnected, So exercise and bring all the other components, and why to waste the time and the resources and don't capture all that. Even at the end, if you collect all that data, you can use artificial intelligence and have more data with the population that are using the services. So I know it's really wide idea, but everything is connected. You're bringing them and you have to take advantage of all the different components at the same time, But
Yes.
I have a question.
Mhm.
How concerned are you about privacy? As you mentioned facial recognition, what about concern about privacy?
Well,
I don't want to be recognized, I don't want people to be done.
that's a good point. I mean, the app is kind of the nexus to get involved in that part of it. It's totally voluntary. You don't have to use the app. You can just come along and do something, passive and get out and get in the fresh air and walk underneath the underline and take advantage of everything there is to do there without necessarily going on an app.
But a potential solution for that is I'm saying that you can actually divide the level of information from the facial recognition, is that maybe only track your eyes or your nose or your lips, so you're not fully recognized. This is not for you, it's for the matter of the objective of the application. You see? It's not that next time you go there, we're going to tell you you were here yesterday. It's pretty much like a kind of data collection for other purposes. But if that is a concern, I think that basically we can split that facial recognition information into different components that will not allow.
I think in any kind of accumulation of data, they had this issue in New York City, for example, when they were using large data where they could actually look into buildings and they were looking at how much energy buildings were using, and they could actually look into the building. And one of the big things that they were worried about was people's concern about, they have too much information. They can zoom in on what I'm doing during the daytime. And I think there's that balance of, of your privacy versus collecting information.
Even if you make the interaction with the app optional, what stops somebody's face being recognized without them knowing, from a certain distance from that? Like somebody that doesn't want to interact with it, is there a possibility that they can still be recognized?
It's a good question. I haven't thought about that.
Okay, last question before
We started from a basis of what's it mean, what are we really trying to do, okay? Because it doesn't matter if we get to the end and everyone uses it and it doesn't do anything good. We wanted the end result to be people are healthier, however they choose to engage in that. And the end result is we wanted more social interaction and more inclusion, more diversity. Based on those two objectives, we tried to design something like that.
That's the last time.
Tiananmen Square? Alright. So I'm Riza Plaza, work for the City of Pro Viejo's IT department, and
I'm Ebony Ross. I'm a civil engineering student here at UM.
shout out to the artist over there. So this is our community green project. The point of this is to bring the community together and have a place where they can meet, as well as bring up economic development by having businesses here. So we're starting off by creating a space where you can walk and bike through it. So we'll have a bike path and a walk path. With LED lighting, so you can do this at night as well. You don't have to come during the day only. And there'll be sensors on these paths that'll count the people that go through it. We'll collect that data, and of course, depending on whatever information we get, we'll be able to give that to businesses such as a farmer's market, or food trucks, or different street vendors. And they'll be able to pick which days they would like to rent out, and they'll be able to basically sell their goods during their busiest times. So that's it for me. I don't know.
So pretty much on the macro level, our big idea is the economic development within the community, giving back to the community by having the market there. And as she said, the censoring in the path is going to allow us to pick peak days for vendors to be there. And then on a micro level, within the aesthetic of our design, we have, like she said, the LED lighting for the bike path, which would provide pedestrian safety at night, and also give it a little like color and interaction. And we also would have green space along the sides of the bike path, thinking that because this is a transportation type area, you have the rail, you're gonna have like little pollutants environmentally, like oils and stuff like that. So we wanted to introduce, which would be in the background, we would have rain gardens. So in the rain gardens, it would be self-sustainable. You wouldn't really have to manage it because it can survive in an environment that doesn't need much water, and the plants can also take care of whatever oils will be spilling. And this will also increase the outdoor air quality within the area. And also for potential add-ons, not implemented now, but possibly in the future, we thought we could implement impact on the bike path that could contribute to energy, also providing along the path exercise stations that at night would have solar panels over it that would provide lighting at night, and also power stations.
And so we can further develop this park as well as we go. We're starting off with just the walking path and bike path and the greenery. And then we'll use the rent from the food market and the street vendors to keep developing. So that's pretty much it.
So originally you were saying something about economic development, convergence that will be along this. So do you envision that convergence will be something like pop-up stores along your path?
Yes.
Something like that?
That'd be mobile, everything would be mobile.
And like assigned spaces that can be sought after?
Yeah, we have designated spaces where they can rent that space for their truck or their kiosk and stuff.
So regarding that, we thought economic development should be a main point of this because it takes money to build something like this. So we create the support the local community. So we have to find ways to continue to build the ecosystem.
Also, we also thought educational-wise that having longer down the line kiosks along the path too for people to learn about rain gardens, and also anything technology-wise that we implement within the design.
What infrastructure do you need to support this solution?
Which
For the bike path and all that?
The main thing you started with was these assignable spots for
So we have
the counter.
we have the people counters, so there's basically sensors throughout the paths that will count foot traffic or bike traffic. And that would be available to businesses on our website, for example, and they can see when the highest foot traffic is going on, and they can Is that for the business? Any questions? All right. Thank you.
What's your school name?
Starts with a Z. So cow.
Yeah.
Hello, my name is Ben Thomas. I'm a systems analyst for the city of Coral Gables. And for us, when we first started with what's the problem. One of her from Mexico, she recently worked on a park, and she said crowding was a major over issue. It was either boom or bust. Everybody would come at the exact same time. So what we thought was our design material. So what would happen would be like the underlay. People come 2 or 3 times, and it's shoulder to shoulder, and so they go home. It's 110 degrees, they go home. Or maybe it's somebody that really likes crowds, and it's empty, so they go home. People do that 2 or 3 times, and they don't come back. Then you have a beautiful park that nobody goes to. So our design criteria was cost effective. It had to be actually implementable, not something that, was pie in the sky. And it had to be useful for people actually that wanted to come to the park. So our idea was we'd set up sensor clusters, every half mile or so along the park, and that would give you humidity, temperature, congestion. Congestion is just how many people are in there. That's an easy trail camera or anything like that. That's just counting how many bikes, how many people walk by in a 15-minute period. That's easily doable. And you put weather in there too if it's raining, if it's overcast. So our idea was we would take that and we would actually get from all those an aggregate score for each activity in the park. If you're running, if you're walking, if you're with your kids, playtime. Because it's going to be different from everybody. If it's really crowded, you can't ride your bike on a path. Or if it's 100 degrees, you may say, hey, I'm only going to have my kid out there for half an hour. So then it'd be just at every entrance to the park, simple. Just when they were showing the smiley faces earlier, it goes from smiley face to frowny face. Just so as people are walking by, they can just look. And that would be the simple part of it, just so people coming in and out. Our idea was also to have all that information be going into an app. And from the app, you could be at home and say, hey, it's 80 degrees, there's only a few people there, especially on this one place, that's where I want to go. So you could actually look at your app, and it'll be, frowny face, medium, happy. Let me go to this one right there where it's not very congested. And then as the system gets data, especially if you're logging into an app on your phone, you could set your own preferences. Hey, 80% is how many people there for me. Either I don't want people or I want people. Temperature, I'd rather it was 90 degrees. And as it learns about what you want, it would be giving you, hey, this place is perfect for you. Here's where you want to go. And so, just to keep it simple, here we design our app. And you could also, your friends. Hey, I checked in on the app. My friends at the next one, or wherever they know I'm here, come over to where I'm at, and we can have a good time together. And that's pretty much it. Any questions? Sure, okay. Oh, I never really said hardware, okay.
One thing that how you're going to solve the problem with the dynamics of the train delivery of people, because it's out every 10-15 minutes, you're going to have people dropping out. It may be empty now, 10 minutes later where you are, it's going to be crowded.
You're correct. Like I said, it would have to be dynamically updated. It wouldn't be, you'd have to be watching, because you're right, because everybody says, hey, this place is empty, and everybody run over there. But that's true of anywhere you're going. I agree with you on that, but you would have to be, the sensors would have to be in real time, especially when you're looking at the app.
Would you have any forecasting for when the high points are going to be, like, the next day?
That's
so you can plan ahead.
very good idea, because I know you're into data analytics. You after a while, when you're collecting that data, people will be able to see, okay, these are peak times, these are low times, and everything like that, and plan accordingly.
So about you mentioned the smiley faces that this is the place for you to be. How do you envision that works when you have multiple people on the path and they have conflicting preferences about whether it's...
That's what I say, like for like the entrances, it would be just like an average of what people like. But on your app, as it's learning about you, say, hey, I like it when it's hot, or I like it when there's not people here, like that. It would learn for your personal preferences. And you could even say, like a slider, say, temperature is really important for me. Humidity is not that important. Weather is important. And so it'll be able to match what you're actually looking for.
Thank you.
Thank you.
Answer question?
Yeah.
Why not? So, a common theme across everybody's projects has been creating almost like an oasis for relaxation and community gathering. And a big issue that we foresaw with that is that illusion of an oasis gets broken every 30 seconds when someone honks their horn on US 1, or every 2 minutes when a metro rail goes overhead, or every 5 seconds when someone gets mad at a fellow commuter. So we were trying to see how we can mitigate sound in the underline. So we did it through two ways. We were trying to create this calm, relaxing environment that's embedded in nature, but also uses technology to gather data and produce a relaxing and a calm path through the park. So two things. We're looking at landscaping on how we could make use foliage to mitigate sound, blocking on the borders, and wherever the big intersections are, you can make denser foliage or what have you. And also for the overhead metro, there's not really any foliage that's going to stop that sound. So we are looking into more technological advancements in the noise canceling field, where we could have microphone arrays that gather sound inputs and then can use a machine learning API or anything that can work with that sound input and create a output of music that can kind of theoretically cancel out the sound of the metro. That's pretty much it. Is there anything else we should add? Hardware? The hardware is going to be, we're going to have, theoretically, we would have sensors at any station where the metros are coming in, and any intersection where cars are going through the park. And we'd have speakers at, strategic locations so that the sound is all inclusive and overlaps everywhere. That's pretty much all. Yeah, any questions? Cool.
So it's all basically about the main sensor of the sound sensor. And so how do you imagine it's going to be, where would the process be? For this?
Yes, the computing. Yeah. We are told to keep this specific, so I didn't want to get too much into the network infrastructure, but I would imagine that a lot of this would have to have some connection to a cloud computing because we're not going to have any computing services on site, I would imagine. So it would send it up through internet to some offsite service that would then be able to send something back. Again, we didn't get too much into that infrastructure in our planning, but yeah, that's about as much as I can touch on that.
Is it
Yes.
I never other questions? It's easy to talk about, but it's a lot harder to actually produce an idea and see it through. And you've all, worked very hard and came up with a whole bunch of ideas before you narrowed it down to the ones that you developed further. So what happens next is the judges will convene, and we will discuss, and then we'll come back in 5 minutes for the announcement of the winning team. 10 minutes. 10 minutes. So 10-minute break.
And we should all take heart in the fact that it actually took us about 15 minutes to do it because we really couldn't come to a conclusion which one was the best. However, after multiple discussions, we finally figured out which one we think will actually be able to move forward and actually has a future. Team Sokol, where are you, please? All right. Congratulations. Thank you. The Judges Committee, first of all, I'd like to thank everyone, obviously, for coming out. There were outstanding ideas from everyone. As a computer scientist, I'd encourage everyone to take a look into the state of art of face recognition and sound for it. It may not be what you think it is. We liked your idea. We thought it was wonderful. My colleagues in the architectural school would say, or have the idea that to take it to the next real level and to make this not just a doable one, but to make it something that the architectural world would enjoy, it would also be to look at different lighting conditions and other things that you do. We feel that there is a great deal more you could do that would impact the actual reception of that by more visual indicators. We thought the idea was very good. My fellow judges, any comments from the room as well?
We have some awards for you, so let's first do any other comments. So the discussion was very lively.
Spirit.
It was very lively and it was very difficult for us to decide because all of the projects were very good at one thing over the others, right? So how do you decide then? And it came down to what Joel just talked about. So I'd like to present you with the actual awards. So there's 4 members of your team, correct? Yes. Yes. So this is the award that says that So it says Hacking Main Street Workshop Best Concept Design. So
thank you.
Congratulations. And there's one for each of you. Do you want me to take them out?
I think fuck you.
For the picture? Okay. Do you want to come up?
We want the
First we have TV, now this. Look at Bryce's face.
And one more? Where's the fourth?
Did you want me to take a picture for you? No, no.
Come on, Chris.
No, I'm not part of that team. I was just sitting there.
Thank you.
Too bad there wasn't a game.
also mentioned that the Miami Foundation has a public spaces challenge that you can submit these ideas to. So if you'd like to do that, to maybe perhaps get your idea funded, the Miami Foundation. Yeah. And we'll pull up the website so that you can make a note of that and take this to the next step. So thank you everybody for attending and for brainstorming with us and for being so creative today. And we'll see you next year.
Thank you.